Hi and Assalamualaikum. My name is Shalom Fikri bin Muhammad Latifi and my partner is Muhammad Faiz Wajidi bin Azhar. For this assignment, we was assigned to design a switching power supply that produce a DC output voltage between 0 volt to 60 volt with AC input voltage to 40 volt in RMS. For this assignment, we must specify the duty ratio, inductor and capacitor value and compare it with hand calculation and MATLAB simulation. In this question, we use the CCM method, which is continuous inductor current mode. In this assignment, we use the 60 volt as the output voltage in the buck converter, and the input voltage must be the value of RMS must be converted to the peak value, which is 240 volt RMS multiplied by 2 and get the 339.4 volt. For the switching frequency, we use the 30 kHz. And the next step is we must calculate the duty cycle, which is VO over Vin, and we get the 0.1768 volt. And for the resistance, we get the 18 ohm, which is V power of 2 divided by power. Next, we calculate the inductance and capacitance value. For inductance, we use the formula 1 minus D multiplied by R and divided by 2F, and we get the inductance mean 0.24696 millihenry. And for CCM method, the inductance actual is 25% higher than the inductance mean, which is we get the new actual inductance 0.3087 millihenry. For the capacitance, we just rearrange the formula of ripple and we get the value of capacitance 7.4074 microfarad. For inductance current, we use the formula V out multiplied by 1 over R minus 1 minus D divided by 2LF, and we get the inductance current mean 0.67 ampere. And for the inductance current max, we get the 6 ampere. For delta IL, we get the 5.33 ampere, which is the difference between IL max and IL min. For the output voltage ripple, we get the 3 volt. So we move to the simulation part in the MATLAB application. So this is the circuit of buck converter in Simulink. Vin, we get the 340 volt. The out max is 60.5 volt and the out min is 58.1 volt. For the inductance current, I max we get the 5.988 ampere and IL min we get the 0.6112 ampere. For the duty cycle, we get the 0.178. For switch frequency, we get 30.176 kHz. And for the output voltage ripple, we get 2.86 volt. In conclusion, we can say that the manual calculation between simulation result are approximately same. For example, for the switching frequency, in manual calculation we get the 30 kHz, while in simulation result we get 30.176 kHz. And the voltage of a ripple in manual calculation 3 volt, while simulation result we get 2.99 volt.
Hi, I'm Muhammad Faiz Wajidi and I will tell about question 2. Question 2, we have to use magnet signaling to design the converter feedback controller. Proportional and integral pi is used in the controller design. Determine the crossover frequency and the phase margin of the open loop frequency response. Evaluate the converter steady state and the dynamic performance by showing and analyzing the appropriate current and voltage waveform. Okay, first we have to build a circuit that have PWM and a buck controller. First, after we build the circuit like this, we have to assume the value of Kp and Ki. Okay, the assumed value we get Kp equal to 0.33 and the Ki value we get 1000 value. Okay, then the value of assume we will enter the value inside the pi controller and run the circuit, and we will get an output waveform at the scope at the behind of the circuit. The waveform show like in this picture. We can see that we get the value of 60 volt that we from question 1, and they have a high ripple in the waveform. So in the question 2, we will reduce the ripple by calculate the new KPKI and other things. Okay, then after we get the waveform, we will use a linearization waveform function to get a board diagram. As we can see from the board diagram, we will find the frequency that we use inside the manual calculation that equal to 30 kHz. And as we can see at the phase difference, the value are equal to negative 149 degree. So that negative 149 degree are an unstable value. So we will have to create a environment that will make the circuit equal to the stable value. So we will have to find a new phase that have state that equal to stable state. The new phase are equal to 180 minus 45 degree. So we get 135 degree. Okay, then we will find the magnitude. The magnitude are equal to 60 dB. We get from 20 log Ki. Then we will use a formula, shift down formula. Shift down formula are used to we used to reduce the ripple. The shift down formula are equal to 60 dB minus 44.3 dB. 44.3 dB are value from the stable state. The shift down value are equal to 15.7 dB. Then after we get the shift down value, we will have to find the stable value of Kp and Ki. The stable value of Kp and Ki, we have to find the new value equal to 20 log Ki equal to 50.7 dB shift down value. The Ki value we get 6.1 and the Kp value we get 0.0061. Okay, then after we get the value of the new stable, we will have to insert the value inside the pi controller and run again, and we will get the stable waveform like this picture. Like this picture. Okay, the new picture we can see the value of voltage output still the same, 60 volt, but the new ripple decrease. So we can see that they have a bit different between the ripple value. Okay, next we move to the buck converter. The buck converter circuit are equal to like this. Then we will insert the value of the stable state inside the PI controller, PID controller, that equal to 0.0061 and 6.1 value. Then we will run the buck converter and we will get the duty cycle of the circuit. The duty cycle of the circuit equal to 0.1765 we get from the period of time of the waveform equal to 33.139 microsecond. Then we will find the value that equal to 0.1768. Okay, then after we run the buck converter circuit, we will get the voltage and current measurement. The voltage output equal like this, that we really get a linear DC voltage, and the current measurement are equal to like this, the sawtooth waveform. Okay, from both diagram we can see that the voltage measurement, the max value of 59.92 volt and the minimum value of the circuit 57.73 volt, while the current measurement are equal to 6.031 ampere, and the minimum value are equal to 0.67 ampere. Okay, from the diagram we can get the new ripple, and the new ripple formula are equal to theta V naught over V naught times 100%. The max value of voltage measurement we will minus with the minimum value, minus we will divide by 60 volt that we have choose and at the earlier task. Then the new voltage ripple we get 3.65%. So according to question, we have satisfied the requirement that equal to voltage ripple are approximate to 5% or below. And from the voltage and measurement graph, we can see that both value of voltage and current are same with the manual calculation at the early at question 1. So we have succeed the task that we have to get a voltage ripple that approximate to 5%. Thank you.